before I start making any announcements. So a few items, I sent an email out to the class yesterday morning. Again, I don't mean to bombard you with a ton of emails. I do it because I'm hopeful that it'll help you keep track of where we're at and like what's on the docket and what's due. I know that, you know, juggling multiple classes can be kind of rough. And so if it helps you keep track of due dates, cool. If they just irritate you, then you don't have to read them. But just make sure you're aware of what they say. So in particular, your lesson 6 online homework is due tonight by midnight. And the activity number 4, that medical testing, is due by the end of class time today. Those of you who are here in the room, make sure you hand it in. And those of you who are going to submit it to me via email, please make sure you email it to me by noon, because at noon I'm going to make the solutions visible. And at that point, I just can't accept any more of the assignments. Cool. Okay, other thing, activity number 5, I have here in class right now, printed copies. And I also want to show you, I'm going to go to the Moodle page in a second. I just want to make it look right for y'all. So if you go to the Moodle page and you go to class activities, this is class activity 4. By noon today, you'll see the solutions to it. And if you were here last time, you know the solutions to it. And here is the next class activity. This one covers both lesson 6 and 7. So you'll have some conditional probability with a given tree diagram and a given Venn diagram. And you'll also have some binomial to compute. Cool. Awesome. All right. Does anyone have any questions? Yes.
I know not the questions, but I know if you help with mine, I put similar questions. So I have a top number. So give a number like.
Yeah, let's do it. Will you read to me what you have?
Yeah. So mine is probability is 0.74 and A and B is
0.1. Okay. And you want to find the probability of what? Given not A. All right. Thank you for asking a question. That starts my day out so well. Okay. So what we want to do here, this is number 2 in lesson 6. And I forgot my calculator up in my office. So if you want me to, if people have questions of like binomial where I would actually need a calculator, I might ask to use somebody's, but this one does not pertain to that. Okay, what you want to do with this one is you want to draw a Venn diagram. And let's fill in this Venn diagram. Where do we start? In the middle. We know this is 0.1. Okay, so if we have this is 0.1, now we can work out. So if the probability of all of A is 0.16 and we've accounted for 0.1, what should go here? 0.06, good job. Okay, if the probability of all of B is 0.74, and we've accounted for 0.1, what do I put here for the only B? Don't I have 0.64? You with me this far? Okay, now what we have to get is this region out here. Well, we can add up everything we have here. So this is 0.74 plus 0.06. What does that give us? 0.8. So don't we get 0.2 out here? Any questions this far? Okay, so what we want to do is we want to find the probability that B doesn't happen, given that A doesn't happen. So what we're going to do is we're going to reduce our sample space down to not A. Okay, do you agree not A is this region and this region? So 0.64 plus 0.2, which ultimately is going to give me 0.84. Okay, from this reduced sample space, okay, are we interested in the part that is in B or not in B? Not in B. So what you're going to do is compute 0.2 divided by 0.84. Thank you for asking. Are there other questions? Happy to do any other questions anyone might have from lesson 6. Okay, what is it?
The company, the factory is 27 RNA recipe, 10% in A are defective, and 22.
Okay, 10% in A are defective and what in B? 22%. Okay.
If a defective appliance is selected, what is the probability?
All right. So those of you on Zoom, I'm sure you probably couldn't really hear. But what the question was number 8. And I wrote down specific numbers that this student was asking. So essentially what we have is that products come out of factory A or factory B. We were given that 27% of them come from A and the rest come from B. So if these need to add up to 1, would you grant me that if this is 27%, that this then needs to be 0.73? Okay, now the other piece of information that was given, well, one of the other pieces of information that was given is of those coming from A, 10% are defective. Do you agree that that means that 90% are not defective? And then we were given that of those that come from factory B, 22% are defective. Well, if 22% are defective, what percent are not defective? 78. Okay. So again, for numbers 7, 8, and 9 in lesson 6, you got to draw a tree. Okay. Now, this specific question said if a defective item was selected, find the probability it came from A. Your question might say if a non-defective item was selected. So you need to be careful for your particular version. And Sally, I really appreciate you. Okay, so make sure that you're doing your specific question. Okay, so we're assuming that the item was defective. Well, how can it be defective? It can come from A and be defective, or it can come from B and be defective. Okay, now this is what we narrow our sample space down to, kind of like, I'm just going to do this real quick, kind of like with this Venn diagram. We reduced our sample space down to 2 different scenarios. And from those 2 scenarios, we need to pick the one that we're interested in. And in this case, we're interested in it coming from A. So we put this branch in our numerator. Does that help? Cool. Number 3 on the online homework, Isaiah.
Yeah.
Isaiah, I'm assuming, yes, that you want me to do number 3 from the online homework. Let me get it visible here. Lesson 6, number 3. All right. Yeah, okay, cool. Just want to be sure I'm doing what you're asking me to do. All right, so number 3 on the online homework. I'm just going to do this version. What I'm doing is I'm sharing my screen with you so I can read off the problem, and then we'll work it together on the paper. So note that your numbers are most likely going to be different than mine. But the overall question is about the same. And we want to find the probability of B given A. Cool. So what I've now done is I've written down what this problem states. And so what I'm going to do for this number 3 as well is use the hint that we would like to draw a Venn diagram. Okay. So here's A, here's B. What number do I put in first? The middle, 0.1. All right. Well, if the probability of all of A is 0.56 and we've accounted for 0.1, what goes right here? 0.46. Stop me if you have a question. Okay, if the probability of all of B is 0.34 and I've accounted for 0.1, what goes right here? 0.24. Okay, now technically I don't need this value out here in order to do the computation they want me to do, but I'll just do it anyway, just for the sake of completion. Okay, so what is my union add up to right now? Well, this is 0.56678. So what goes here? 0.2. So what we want to do is find the probability that B happens given that A happens. Okay, well, if we're reducing our sample space down to A happening, I'm reducing my sample space down to what's in A. Okay, so that's 0.46 plus 0.1 or 0.56. Now, from this reduced sample space, we want to find the probability that B happens. Well, which portion of A also includes B? 0.1. So what you're going to do is compute 0.1 divided by 0.56. Wasn't that fun? Yes. Okay, how about this? How about this? Given, I want you all to pay attention to my words. Given that we're in a math class Wasn't that fun? So what am I doing? I'm reducing our sample space. I'm reducing our experiences down to being in a math class. So of your experience of being in a math class, wasn't that kind of a fun thing to do? See how great it is to reduce your sample space? Then you can make things actually seem like they're not as bad as they were. Anyway, okay. All right, so I encourage you all over the weekend as well. Number one, to enjoy yourselves and do some fun relaxing. It's beautiful weather. But number two, I also want to encourage you to please work through the lesson 7 online homework. We went through a few of the examples in class here. And Libby, do you mean from lesson 6? Okay, yeah, I'm happy to do that. But then, so there's just a request for me to do number 9 from the online homework. So I'll do that, and then I'm going to jump into lesson 8. I want you all to please be working through lesson 7 because some of the stuff we're going to be talking about in lesson 8 at the tail end is going to involve binomial. Okay. I do want to say that lesson 8 doesn't really contain a whole heck of a lot of new material and new ideas. It's just a way of looking at organizing our information. So I will do number 9. What do we have here? We have a video game. So we have that a company is marketing a new video game. And it's a matter of whether you see the advertisement or not, and then whether you purchase the game or not. So I'm going to simultaneously read this and draw my tree, at least with what's given. So we're given that 17% of the market has seen the advertisement. And then we're given that of those, 48% purchase the game. And 85% don't, who haven't seen it, don't purchase the game. And we want to find the probability they saw the ad if they didn't purchase the game. All right. So what I did is I started drawing a tree. We'll fill in the rest of it. We're given that 17% of the people saw the ad. Well, what percentage then do not see the ad? 0.83, good, has to add up to 1. Of those who saw the ad, we're given that 48% purchased the game. Therefore, 0.52, right on. And of those who don't see the ad, we're given that 85% don't purchase the game. Therefore, what percent do? 0.15. Thank you. You with me on the tree? Now, what we want to do is find the probability that they saw the ad if they did not purchase the game. So we want to reduce our sample space down to not purchasing the game. Well, how does that look? Either they saw the ad and didn't purchase it, or they didn't see the ad and didn't purchase it. From this reduced sample space, are we more interested in, which branch are we interested in? Aren't we interested in them seeing the ad? So I would put that branch in my numerator. Hey, Libby, does this help? Or do you need me to explain anything additional? Cool. I'm happy to help. I am very happy that you asked questions. All right. Ready? Cool. Lesson 8. These involve what we call probability distributions. On a lesson 7 homework, I'm not, I think, oh, it's due next Wednesday because we finished lesson 7 on Wednesday. It's also in the email that I sent. It should have the due date for lesson 7. Okay, let me write this down. Lesson 7 online homework is due next Wednesday. And this is all in the email I sent yesterday. And the next activity, number 5, is due a week from today. Thank you. All right, so what we're talking about in here is actually a lot wordier than how deep we're going to be diving, in the sense that I claim we've already done probability distributions. It's just a different way of organizing our information. Okay, expected value is a new concept, and we will motivate that. And there is a formula that you will use to find the expected value. But I'll show you where that formula comes from, because I claim it comes from stuff you already know. But we won't be getting into expected value until next week anyhow. Okay, so I'm going to start by giving you a definition, and it's actually something that was brought up in lesson 7. In terms of this definition, number 1, I obviously never ask you to memorize any definitions, but it is important that you know when you see this word or these words, what it is we're talking about. Okay. And it came up actually on Wednesday in class as well, when I did an example out of lesson 7. So a random variable, and you're not going to love this definition. I'll make it seem a lot clearer in a moment, but it's a function that assigns a real number to each outcome of an experiment. Now, I like to give precise definitions. It's just the nature of who math people really are. But what I want to say is don't overcomplicate this. Okay. So I'm assuming at some point everybody was in an algebra class or looked at algebra. Okay. And one of the things that you notice about algebra is we like to use letters a lot instead of numbers. Okay, so when we talk about like some fixed number, we call that a constant. But we also like to assign variables to represent certain things, precisely because the values can vary. Okay, that's the whole reason that why we call the term a variable. So, I mean, I think my best example is, suppose I let X represent the number of people in Math 115 who come to class. That's not going to be a constant number, right? That's going to vary from day to day, week to week, whether there's a test occurring in class or not, right? Do you all agree that X is going to take on different values depending upon the class session? Okay, that's what we mean by a random variable. Okay, so when it's something that can change, we call it a variable, and we usually set X to represent that. Y'all with me there? Okay. So let me just go to a particular experiment. Suppose you toss 2 coins and you are interested in counting the number of heads that appear. I always like to take us back to some of the more basic experiments. Do you agree that the number of heads that can appear is going to vary from trial to trial? Okay, so because of that, what I'm going to do is I'm going to let X represent the number of heads that appear. How did I know that that was what I was interested in? Because I was told, right? You toss 2 coins and you want to count the number of heads that appear. What values can X take on in this particular circumstance? What are the possible number of heads that we could have appear if we toss 2 coins? Don't think. I tossed 2 coins. I could have 2 heads appear. What else could I have? Okay, I could have 2 tails. In other words, how many heads appear then? 0 heads. And I could have 1 head, right? If I'm tossing 2 coins and I want to count the number of heads that appear, X could take on 0, 1, or 2, right? And we could write our sample space here, knowing that we could have head, head, we could have head, tail, we could have tail, head, or tail, tail. You with me there? Now, one of the things that we like to do, whereby we have the title of this section, is we like to make probability distribution tables to organize our work. Okay, so I'm going to show you what one of these tables looks like. Okay, X is my random variable. And what I'm going to do is say, well, X can take on the values 0, 1, or 2. And what I want to put underneath is the probability that that event happens. Okay, so the first thing is identifying what possible values X can take on. And now beneath that, we want to find the probabilities. Okay, well, we have our sample space right here. What is the probability that we don't get any heads? Well, how many times does that happen? 1 out of 4, right here. How about the probability of getting 1 head? In how many places does that happen? 2 out of 4. And yes, I'd write that as 1/2 normally, but there's a very specific reason why I'm not reducing my fraction here. And what's the probability of getting 2 heads? 1 out of 4. If I add across here, do you agree that the sum of these probabilities is 1? 1/4 plus 2/4 plus 1/4 is 4/4. Okay, that's something important to keep track of. This is going to happen. And I'm going to say sometimes, though, within round off error. Because sometimes, like if I threw a probability distribution table at you that you had to use combinations to compute, we're going to be rounding. And so sometimes, you know, there's some round off error. So maybe it'll add up to 0.9999 or, you know, 1.0002. All right. And then I'll breathe really hard and it'll fall. Yes, but that is true. I know. The funniest thing is my daughter and I were deciding the other night where we wanted to, I take her out for dinner once a week and we were deciding where we wanted to go. And she said, well, here, I found a coin on the ground. If it lands on a heads, we'll go here, tails on a here, and we'll go here. And not only did it land on a head, but she flipped it, it landed on a head on her head. And we were like, oh my God, we have to listen to that. Anyway. Yes, okay, my interesting life. Any questions here? Now, these can get funky, okay? I don't intend for us to get super funky, but I do want to throw one more example up here today that's going to bring back something that I will not put a question like this on your test, but we can have these probability distribution tables come from, for example, combinations. Okay, so let's do this. Suppose you have a bag of marbles that contain 4 blue and 2 purple. Suppose 2 marbles are selected at random and the number of purple marbles is counted. Okay, so the first thing I'm going to ask myself is, what is it that we want to count? We want to count the number of purple marbles. How did we know? Because it told us. I mean, literally, you're going to be told what you're interested in counting. In this particular scenario, what values could X take on? Well, what's the smallest number of purple marbles we could pick out of this bag if we're picking 2 marbles? 0. What else could we have? 1. Anything else? 2. Could we have more? No, we can't have more than 2 purple marbles for a couple of reasons. Number 1, we're only picking 2 marbles, so we got to stop at 2. And number 2, we only had 2 purple ones in there to begin with. Okay, so we're limited. All right, so my hint here is to use combinations. Now, if there's any combination sort of question on your online homework, I will give you the hint before I make the assignment of the online homework. But in this case, since we're doing it together, I feel very comfortable that we can use our combinations. So again, the first thing I put in is 0, 1, and 2, because those are our only possibilities for X. Okay. So now what we need to do is find the probability of getting no purple marbles. Okay. Well, This involves a fair amount here, my friends. What does it mean to have 0 here? Doesn't that mean 0 purple marbles? What does that mean that we picked then? That we picked 2 blue. Remember the whole thing with combinations, first translate, then account for the rest of your sample. What does this 1 mean? Well, it means that we're picking 1 purple marble. Well, if we're picking a total of 2 marbles and one of them's purple, what do I know about the other one? It's going to be blue. And in this last situation, we're counting the number of purple marbles. And here we're talking about 2 purple marbles. Well, if there's 2 purple marbles, do I have any blue? Nope, because I'm only picking 2 marbles. Oops, I put the wrong one in front. There we go. Sorry about that. All right. So how many total marbles do we have in our bag? We have 6 marbles in here, don't we? So won't each of my denominators be 6 choose 2? Because that's the total number of ways you can pick 2 marbles from a sample of 6. Order doesn't matter. We're not being specific about that. Well, in our numerator, we want to put the number of ways we can pick no purple and 2 blue. Well, what's the total number of purple marbles in my bag? 2, and we have a total number of 4 blue ones. So that's not going to change here. And in this case, we want no purple and 2 blue. In this case, we want 1 purple and 1 blue. And in this case, we want 2 purple and no blue. All right. Fortunately, even though I don't have my calculator, I know these numbers just because I've computed combinations a couple times in my life. Sorry. So this is going to give you 6/15. This is going to give you 8/15, and this is going to give you 1/15. If you don't believe me, compute 6 choose 2, and then compute 4 choose 2. Trust me. Thanks. Totally not a liar. Well, check this out. What do these add up to? 15 over 15, which is 1. Okay. Now, I want to ask you a question here. Okay. Which is the most likely outcome? Just looking here, 0 purple, 1 purple, or 2 purple? 1 purple. How'd you know that? Because it has the highest probability. Do you agree this is the most likely of the outcomes because the probability is the highest? What's the next most likely outcome? 0 purples, right? And then the least likely outcome is that both of them would be purple. You with me there? Cool. All right. What? Are there any questions this far? Let me stop here and ask that. All right. Anyone on Zoom have a question this far? Okay. You know, I think the next thing that I want to start is actually going to take a little bit long. Oh, I'll start this. I'm planting a seed here. I'm going to ask you a seemingly very random question. Okay. suppose you took 3 tests in a class. Okay, and these are your 3 test scores. And I know this is going to seem like out from left field, but it's really not. But you're going to have like this waiting until Monday to see why not. Okay, so suppose these are your 3 test scores. And suppose this is how your entire class grade was determined. Could you figure out what your class average is? Does anyone know how to find their test average?
You add them all up and then divide by 300. Right? No, you divide by 3. Add them all up, divide by 3.
Good. Okay. Well, because that's the total number of points. You're right. What you do is you take each of the values, you add them up, and then you divide by the number of things you're adding. It's a really good thing to know how to find your average. Okay. So in this case, if you do the computations, you would get 75.3 repeating. Okay, which makes sense given these values. Do you notice how your class average is not actually one of these test scores? And very often you get funky decimals just because you're taking, you know, a different number of values of things and you're dividing. Okay. So is everybody clear about how you find the average of things? Okay, we're going to get more into this when we start statistics soon. But what I want to point out and what I want to leave you with today, other than the class activity number 5, is the following. When you compute the average of things, more often than not, you don't actually get one of the original values. You can, but it doesn't often happen. So what I'm going to be introducing to you next week on Monday is this notion of expected value. Okay. And expected value is essentially your average on a probability distribution table. Okay. In other words, what do you expect will happen? And that's what I was alluding to up here. Don't we expect up here that the most likely outcome is 1 purple and 1 blue? You know, it's brought more a little bit towards 0 purple and 2 blue because this probability is higher. But what we're going to talk about is how do we find the average when we're actually given a probability distribution table? Okay. So my claim is it comes straight from finding the average of 3 numbers or 5 numbers or what have you in general. So this is a good place to leave off. I hope you all have an awesome weekend. Those of you on Zoom, get me your online, your activity number 4 by noon today. That's when I'm going to make it the solutions active. And don't forget to get class activity 5, either from Moodle or from me today or next week. All right, have a great weekend.